Does this one work? Yeah. I was thinking about the hardware when you spoke about cache misses and how, I mean, they actually, the further away from the L0 cache you get, the worse they are, and growing quite fast. How does cache strategies, does that differ in hardware in cars in any way, or is it like, do you have specialized hardware for cars to reduce the cache misses, or is that just the same as in any other hardware?
Yeah, no, it's the same, at least for us. I mean, there are lots of different, even now that we have consolidated lots of it, there are different CPUs. But the CPU that I'm working on, it's a sort of normal ARM processor running QNX as an operating system. So, I mean, it's fairly standard. Yeah, fairly standard.
Thank you.
Yeah. So now when you begin this journey of consolidating, have you had any interesting, unexpected trouble that you couldn't foresee when letting the components work in the one same CPU?
Yeah, I mean, what really hit us was the cost of doing context switches. I mean, so having all of these applications running and then talking to each other, and this is also partly, yeah, due to the whole setup. The cost of doing context switches when communicating, that was really much worse. I mean, we knew that it was a problem. I mean, it's always like when you start a project like this that's quite big, in the beginning, it's just get the features in, because there are others that are depending on the features. We just get the features in. We know that they have bad performance, but we'll fix that later. And then later came much sooner than what we really expected. So that was like the main thing, I would say. And it's been quite interesting to like find all these ways that we can do communication without doing context switches. So putting stuff into shared memory so that we can talk to them between different processes, don't really wake up each other, make sure that there are limits so that we just reduce the number of context switches and combine them together in different ways.
Stops. In some ways, it sounds a little bit like a graphics pipeline. You know, you have to reduce context switching a lot. Would you say it's similar?
I mean, it's similar, but I would say that there are more different things going on here. I mean, a graphics pipeline, there are usually like a few, I mean, you have your rendering part and I mean, a few different things that produces work. And here we have hundreds of applications doing work. So it's sort of the same and still not. But especially like for the autonomous drive part, that is very game-like because it's incoming frames instead of producing frames. And then it's analyzing those frames on a GPU and yeah, doing computation. And that is very like pipeline, graphics pipeline-like.
Okay, I'm going to open it up for questions for everybody else before we get to our main panel discussion. Go ahead.
Yeah, so there's a little bit open, but when you're deciding your boundaries between different applications and where if you want to separate them, like how do you take into account the performance of like messaging requirements between services instead of having them in the same process? Because at some point, creating messages to send between services are going to get costly depending on how big they are and so on. So at one point, do you just start deciding is it more worth it to keep everything together for performance reason, for messaging, and to keeping that down?
Okay, everyone's looking at me. I mean, I tend to see the performance considerations as kind of one of the signals that goes into the decision process. But what I've found is that when you when you get the boundaries that sort of are the right ones, or at least the reasonable trade-off ones, quite often they are ones that fit well with, that there's not massive amounts of data going over them, or it's not sort of, depending on being exactly in time or things like that. So I think one of the, it's very easy to end up with a lot of inter-service traffic if you end up with boundaries that have to be crossed all the time. So if you spot that, I tend to take that as a signal. Well, is this really the right place for it? Is this really where it should be? Because often a sort of closeness of data need sort of implies that there's other things going on. There's often consistency boundaries in the same place, for example, and those you really don't want to cross services. So yeah, I mean it's a consideration, but I think it's one of the stimuli I listen to when trying to figure out where should it go. But to me, it feels like it correlates with other things as well. Does that make any sense?
Yeah. I think that I want to key off something you said there. So there's this question of, are you getting like too much traffic in between different components? One thing that I've noticed is that sometimes people design very chatty protocols that end up that way because they're extremely granular, even though they don't have to be. So asking for each individual row back from your result set as a separate API call, right? There's a lot of times where you want to be able to grab an aggregate as a single call, making that and just say, I want to do this query and come back and get the whole result set. Now you may be streaming the data from that result set. You may be taking it in pieces, but you're not running back and forth on the chatty protocol. Anytime you have to synchronously have two nodes talking to each other, then whatever time it takes to cross that is going to kill you.
But it echoes back even in a single process though, when you
Yeah.
have, it's the same problem as where you have one object obsessed with the data in another object, and it's the same at the service level. It's one service obsessed with another service's data, and the same design failing, I guess.
Yeah.
And I think it's the abstraction point. I like to abstract on a collection, if possible, because usually, this is also from the whole graphics pipeline analogy, that if you want to have something that is processing pixels, you're not interested in the pixels as such. You're interested in aggregate of pixels, and sometimes that's RGB data, but sometimes it's other things as well. And to have an aggregate so that you always work on a whole collection allows for better performance optimizations, because if you have a pixel object as RGB, then again, back to the cache lines, then they are in the same cache lines. But if you're only interested in the red data, then it would be better if you have all the red pixels on the side. And if you do the aggregation on the whole, look at the whole aggregate as the API, then you have better options for optimizing the internals of it.
Anybody else? All right. Well, I'm going to ask a question that's been kind of, part of our subject here, which I think is the morning one. But the thing that I wanted to talk about is the fact that we've all been talking, especially this afternoon, but I think throughout the day, about managing complexity in various ways. And there's some of it that is the managing complexity of just the intrinsic problem space. There's some of it that's managing the teams, managing the process. I guess one of the things that I'm curious about is when you go into designing a project, and I think this question is for all of you, how do you decide where you're going to control the complexity? Because each of us had there were these stories of, okay, well, you can use event sourcing, you can design things that way, you can limit the number of different data engines that you need to talk to. But I kind of wonder, when you sit down at a project, you have some set of requirements for it. Where do you go to start your analysis of how am I going to manage this as it grows in complexity? So,
Yeah, it was a tough one.
I mean, sometimes, of course, you're really lucky to get to make the decision from the start, but often you're not. I mean, on the assignment I'm on at the moment, being patient and learning has been a big payoff. So, there was sort of a realization that the architecture we had wasn't ideal. I mean, it never is, but it was too unideal. So we started thinking about how to do it, and I kind of pushed back a little bit and said, I don't feel ready. I don't feel ready to make the decisions right yet. And you pay attention and you look at sort of the sorts of, I mean, you have to juggle so many things at once. That's part of the challenge as well. It's not just about getting the software right. It's about getting it organized so that the team dynamics will be right, that the deployment will work out okay. And the thing that we're converging on now is absolutely not what I would have done if you asked me to re-architect it at the start of the year. And I'm pretty sure that if you asked me to re-architect it at the start of the year, we'd be regretting some of those things now. But I think one of the things, you say, how do you go into it in the beginning of a new project, unless it's a domain I've worked in before? I try to keep my options open for quite a while, because I know that you need to spend some time learning. You need to figure out the properties of the system, the requirements. There's a lot of stuff that tends to be hidden, that only really reveals itself as you really get into the problem domain.
Yeah,
I think it's the same thing. Going back to the chess computer and problems that you don't really know the path to the end. In those kind of problems, it's nice to have the options open, because you don't really know how you're gonna solve it, and all solutions that overthink it is probably gonna be wrong, because that the final solution is probably somewhere hidden, and you're gonna find it later on. So I also like to keep things open and try to get as much information as I can before I commit to any real processes.
If I should add something from a developer point of view, I will say that those places those times where we have actually removed complexity or maybe avoided some complexity to build up, as well as those cases where we had well-tested code. Those times where we had code where it was well-tested, we dared to change it. So those areas where it was not well-tested, we left it, or maybe started writing a lot of tests around it so we could start dismantle it. So I think test coverage was very key for us those times where we ended up reducing complexity because we had the guts to do it because of the test.
Yeah, that's actually come up a few times today, of talking about the test-driven development, but there's more to it than that. If you have a case where you've got a completely untested system, you need to start by figuring out what the current behavior actually is, so that you can safely refactor it. That's something that's come up quite a bit over time, especially for people who are having to deal with an existing project. I think I'm getting a little feedback, but
I also really like to not expose more than you really need to, and to reduce the input parameters. So I mean, if you can have say that you have some kind of thing that internally it's a value, say 1 to 100, but instead of exposing that as a value, you just start by an enum like low or high, which means that on the inside you get lots of ways to interpret that. You get some feedback from the users of this API that, okay, so how many groups are there? How much do we need? But then on the inside, we can convert these into internal parameters so that we can tweak things. Because I mean, where I work, it's usually, I work mostly with frameworks. That's been my career, basically. And if you have application developers that you can't talk to them, you only have the API to communicate with them, then as soon as you publish an API, then you're really locked into that API. So just keeping that boundary is so tight, so that give them what they need, but never anything extra until you have a real feedback that this is something that's really useful.
A valid use case.
Yeah.
Yeah, I mean, riffing off that a little bit in testing, I think there's a few things that I always find really valuable with tests as well, and one of them is focusing very much on behavior of the object. So often when I'm writing tests, tests and doing test-driven, it's almost a case of restraint. Sometimes you deliberately don't implement as much as you know you're going to need because you haven't written the test yet that it's going to cover it, and there's sort of an interplay there where you sort of hold back and say, well, let's not do that. But I often find that I'm getting into a pattern where I won't write code that if I write something that's I have a function where I can pass in this value, I don't immediately write the code to go and store that. I go and write the next test where something depends on either the internal effects of the object from that bit of data or on some query of it. And only then do I say, okay, now I actually have to commit to putting it somewhere inside of the object. And sometimes you discover, like the initial idea I had of how I'll represent that state was wrong. So that's one thing. And yet, when you do that, you find that you're often not testing details. You're testing the things the object has to do, and then you're figuring out how to do it. And then that avoids having tests of things like private methods. I mean, some people don't seem bothered about testing, privates inside of objects. I really dislike it because I feel that there's this balance you have to strike. You don't want to put yourself in a corner that you can't refactor out of later. And if you test the private stuff, then that's bother. The other thing is, that when I was at science class at school, the teacher always talked about how do you make this a fair test? How do you make sure you're testing the thing that you mean to exercise? Which means controlling all the dependencies of the object as well, which is kind of the co-effect thing I talked about before. So, if you have something dependent on time, you probably need to be able to inject that. So those are two things I found kind of helpful in testing.
I mean, automotive is really, there is an ISO standard for this called ISO 26262, which talks about how to basically the process for creating software for automotive system, and you need to follow this. And they have this called a V model. So you need to do your specification on different levels, and then you have matching test cases for all of those. Which is like, it matched really to waterfall, which is not how we actually do things. So in the end, it's like you start somewhere and then you try to build up this, because we need this for documentation later. But what I really found was that doing all of this documentation and like even afterwards creating these levels, even if they are just conceptual levels of how the system works, is really nice to do that on different levels. And it's really given me lots of things to think about, like how the system as a whole works, that I had the details of how it worked, but now I found out how the full concepts work again, and how that how that maps to the test cases then.
Yeah, question for Niklas. What was interesting about your talk and scenario was that you hit your upper practical bound from the get-go.
Yeah.
Most of us don't really get that far ever in a project. We can sort of anticipate where we'll end up, but in the near to medium future. But the long term is sort of hidden from us. So given that you stumble upon that limit so quickly, has that sort of changed how you take on projects that are more, well, practical in nature?
You don't think chess is practical? Well, no, I don't think so. I think what was kind of interesting about that scenario was that there was a real big community effort behind it. Like the upper bound model was just released in like production. And I think it was an interesting case to see how, all right, how do we sort of learn from what is state of the art and try to adapt that to other projects as well. And I think I learned a lot about how to transform that, because there was no real documentation, and just developers aren't very good at documenting things. So just getting like a sense of how to transform that into something that you can use yourself. And I think that has been helpful in other projects as well. Especially in like the machine learning field, there's a lot of research papers all the time, and well, like it's not often very well documented, and things like Google are not always releasing their source code and things like that. So I think it's important to be able to learn from, all right, here are small insights, how do we combine this into another project and make it sort of as specific as it can be.
Do we have any online?
So, do you think micro monoliths with event-driven communication between are a good choice to not get too overcomplicated, trying to at least not have one giant system? Or is one monolith with event-driven intercommunication still better?
Not sure how to parse that, actually.
She also explained it further. By micro-monolith, I mean perhaps if a company is delivering multiple services to end users that depend on the same data, each one of those services could be one monolith instead of being divided up into 10 microservices each.
Go ahead.
Me? Yeah, oh goodness. I mean, one thing, I'm not sure exactly what you're saying, but one of the realizations that, I mean, I mentioned the architecture situation with the current project I'm on. We kind of have realized that, you know, that there's a lot of microservices in the current design, but actually what we really want is we kind of have free products. Two that face external customers and one which is sort of a internal customer. And we'll organize things around those products. And those might, you know, I think in places things will get more monolithic, and I think in places maybe a bit less. But definitely, I mean, there's costs to distribution. I mean, across process boundaries and things. There's costs to things that are not deployed together, because you have to think about synchronizing the updates to them. There's costs when you have to get into asynchronous processes where you cannot rely on consistency. And I mean, they're all hard problems. I don't think there's a reason to go and enjoy them just for the sake of it. So yeah, certainly I'd say, you know, look for ways that you can decouple, you know, later. Have a well-structured monolith. You know, go and break it up over processes if you need to. But so often, I think once the right boundaries are found, they don't tend to have intense communication there anyway. So you can do the service breakup if you want as well. I don't know if does that answer it at all.
We hope it was answered. And maybe he or she can try to reach Alert afterwards online to ask more specific questions. And we are all done here.
Okay, cool. I think I'm going to use my fantastic powers as moderator to ask a wildcard question. I found it interesting looking at your talk in how you said, like, okay, well, we're just going to do this little contest because it's kind of fun and we all like chess and so on. But in that process, it appeared that you learned a whole bunch about ML and how it can apply to the problem and so on. And you were talking, Jonathan, just a minute ago about, like, you know, wanting to be aware of learning as much as you can about the problem space and so on and so forth. And I'm kind of curious, you know, for those of you who have been on a project or are consulting on multiple sequential projects for a long time, how do you get your learning in? How do you learn about the new technologies when, it could be argued that it is effective for you to just keep doing what you're doing, except even better. And you all have gone and learned new technologies. How do you fit that into your schedule? How do you make it effective and efficient and help yourself grow during that process?
For me, I think it's what I enjoy about the job itself. I think it could be argued that I would probably, from a career perspective, be better off if I just had stayed on one path. But I think it's interesting to learn new things, and I think that also gives you that fire to keep on going. And that's sort of what we did with the workshops. We try and make those fun, because if you have a good time when you're doing it, you're going to learn so much more, and that is going to be applied later on to some sort of business critical application. And I think it just helps you keep on going. If you just sit with the same code base all day long and you never push yourself, well, then I think you're going to get, at least I would get tired of it eventually. So for me, it's that's why I like programming.
Yeah, I mean, one of the things is that there's a lot of new technologies, a lot of new ideas and things, but a lot of the time, fundamentally things are not always that new. So if in a lot of cases you can say, oh, I've seen something like this before. So I mean, if we take a C# example, they introduced the async await feature of Fame, which has been copied into probably 20 other languages by now. But actually, I mean, that idea of you write some code, but actually it's going to suspend at some point, and then we'll come back to it, already existed for generators. And then if you actually go and look into this is a general approach. There's a continuation passing style transform. And this applies in so many things. If you've seen it before, it's just the same thing in disguise. I'm not saying you never ever have to learn anything new, but if you learn sort of the underlying principles behind things, then you find that across languages, across technologies, they repeat. Yeah. What is that kind of makes it seem like you can then just pick up any language and work with it, but there's always so many details. There's always so many little corner cases about how things work. So what I kind of find is I tend to sort of be generalist and then have to specialize in lots of little things. One of the things that I find most educational is having to fix things when they break. because debugging sort of that's where you really have to get into how things really work, and you have to break through the abstraction layers and go and dig and find out what's going on. And one of the most annoying ones that I had kind of recently, we've done a lot of work at Edument in IntelliJ, and at some point I'm like, oh, Kotlin looks so much more fun to write in than Java. And maybe it is, but it's not very fun when you realize that there's APIs that take event handlers, and you pass in some kind of lambda. And then when you want to remove it, you pass it to the remove function. So I think, okay, so I have a handler, so I'll just store it somewhere and then I'll remove it later. My code had a resource leak. Why? Because on the Kotlin Java boundary, it actually wrapped up the Kotlin Lambda object in a temporary throwaway Java one. And I mean, to actually get, I mean, there's so many things you would have to figure out. And that's horrible, because actually you couldn't even see the wrapping in the debugger. It was invisible. It was in the code, the generated code. And this is kind of where it gets icky with learning the different things. There's always these really weird, subtle things that come up. So yeah, I think it's you can learn a lot from solving problems and debugging. and taking a methodical approach to debugging as well, and problem solving. But yeah, that's often where I learn a lot of the ins and outs of things.
Yeah. Somebody raise their hand out there? Oh, something in the corner of my eye. Go ahead.
Perhaps for you, Jonathan. I like the idea of describing the history of programming in terms of like boundaries, and I've often thought about it as just that developer productivity comes from restricting the developer to some extent. You know, like the most freedom you have in assembly, and then everything is sort of a restriction, right? Even the MMU could be seen as a way to restrict the programmer. What do you think is the next boundary, so to speak, if we look forward in time? What kind of boundaries will we see 10, 20 years from now?
I wish I knew. I mean, I think we're starting to see some hints of things that might at some point become more mainstream. For example, you know, if we look at Rust, it has a concept of ownership of reference. So that whole thing I talked about, where I said, well, here's an object, and now it magically references this thing. You actually have a lot more to prove to the compiler that actually you're not going to have, you know, references in bad ways, and that can sort of take a lot of surprise out. So I think maybe we'll start to see that we sort of, I mean, we often talk about type system, but if you look at, say, the Rust thing, then you go and look at TypeScript, and you sort of, I saw this really funny example the other day, which you know, someone was laughing at it and saying, "Has this gone too far?" And I'm like, "That's beautiful." But basically, they were sort of using typing to restrict being able to put together a number and a unit in CSS, so that you actually got it well formed. And I thought that's such a, you know, a nice thing where we don't just see the type checker as a sort of monolithic thing, or a, you know, this sort of thing that gets in our way, but it actually starts to be something that gets into specific domains, and we start to be able to have sort of domain-specific properties of our programs proved, and then we get to sort of go further into that and you know, create those ourselves. And I think there's little, you know, bits of trends going on there across quite a few languages where we're seeing that the sort of traditional idea of, you know, type is becoming sort of more general properties that we can prove about programs. And I think, you know, that there's the research runs way ahead of our industrial languages now. You know, there's things like session typing, which gets into trying to say, well, what are the order of interactions you can do with an object or a service? So I think we're going to gradually start to see, you know, a lot of the things we handle informally start to be things that we can reason about more formally. The thing that's really difficult in all of this is getting the ergonomics right, so that when something goes wrong, the message the programmer gets is intelligible, and it, you know, that's often kind of forgotten. The sort of ergonomics of the whole experience. But I think we'll see that. I'm not really sure to what degree we'll see sort of new kinds of boundaries, but I think we'll definitely see better description and better checking and control, and ability to sort of extend that as we cross these boundaries and wherever they are. Ultimately, yeah, I don't really know whether we'll sort of see a new sort of paradigms arrive out of that. You know, I mean, object orientation is older than me. Functional programming is much older than me, and you know, actors the same. So paradigm-wise, nothing feels very new. It just feels like we're getting better at them, perhaps. don't know what anyone else thinks.
I think there are some interesting features. I mean, in C++, right now, there is this const expr thing that the compiler is actually running some of the code while compiling. And that is like, and the whole meta programming, I think that I really love that in C++. The syntax is kind of horrible still, but I think it's it's slowly getting there. But I mean, to have things like this is checked at compile time, we can prove this at compile time because we have a language that actually runs on the source code while it's compiling. And that is really nice. I mean, from the automotive side, I mean, when we're writing safety-related code, we have some properties that we need. We have like a startup phase and a run phase. And startup phase, you need to allocate all resources. So dynamic memory management, I mean, you have to pre-allocate all of that. You need to create all file descriptors, anything that sort of can go wrong from the system side. We need to do that during the startup phase so that you can't even start the car if you don't have enough memory to run all these processes at one time. And that would be really nice to automate in some way so that you couldn't even compile that program if you use the wrong kind of function during the wrong phase and so on.
Yeah, I think we're seeing an amount of meta programming, which is basically programming, except the data is a program, pretty much. But I think we're starting to see more of that as well. I mean, the Raku language I've worked on has quite a lot of elements of that, where we don't sort of treat the compiler as this sort of thing where it's all a big secret inside and you never get to join in with compilation. We kind of say, well, no, you're welcome to join in compile time, and you're welcome to, try and look at the program and assert some properties of it, or to analyze things and generate them on demand. So, I mean, that's kind of nice. But it's, yeah, I mean, I've actually heard someone saying that C++ is kind of like a library maker's language, because you get to build your world. I think one of the things, Geoffrey, that I kind of struggle with a bit. I mean, I kind of like these languages where you're world building, if you like. But if we talk about scale, if everyone is building their world, that gets hard to scale, right? I mean, I think that's why we've seen, if you look at really big companies, they're not using the world building languages so much. They're using boring language. I mean, I say it in the nicest possible way. It's a positive property. But did I offend your language?
No. I'm yeah. I can take it. Thank you.
Thanks.
Yeah. Thank you. Yeah, I think, there's something to be said for addressing, like, taking the knowledge and all that we've built up in the industry for the last 60, 70 years and going back and applying it to some of the fundamental insights that happened even back in the 50s and 60s. Like the whole thing of having a language that allows you to talk about compile time, that allows you to talk about vocabulary. Forth had that in 1960, 1958, something like that. But it's interesting to think about, like, with all that we've learned about different technologies, different design scales, that, you can go back and look at this problem, look at what the person saw back then and say, I could do so much better because we understand so much more about how compilers work and how we want to talk about them and so on and so forth. So go ahead.
What I think is, speaking of boundaries and the next step for boundaries, I think there's a lot of trends now, like GitHub has its Copilot program and like machines that are actually more than just auto-completion. And I think that's like a trickle line, because it comes a point when that is self-asserting, when programmers are sort of pushed into working in a set of constricted boundaries. And then that code is pushed and the machines are looking at that and then pushing it out and reasserting that. And I think that's a tricky line, because it sort of hampens creativity as well. So I think like finding that sweet spot where that can actually be a helpful tool and not only a way of like restricting everyone to code in the same way, basically. I think that's going to be a challenge.
So you were actually talking about sort of breaking down boundaries between data sources. You know, they've been talking about where are the next boundaries. What kind of stuff do you wish that you could deal with? What kind of things that, you know, either because you're doing MongoDB that it's not handling well, or that you think it's just not handled well in the industry right now, even if you stretch the tools to their maximum?
I still think getting access to data, right? Data is still, before we could get it into MongoDB, there's still some boundaries between that data is produced in some areas where it might be online, offline. It could be the car, for instance, right? So there's still getting data in so we can do some analytics on it, and maybe put some logic that we gain from analytics back into the car. There's still some boundaries there. So we're still in an experimental phase, right? Because the time from it's generated in the car to really gain something, but an accident could have happened, right? So there's still some physical laws that we live with.
Any other questions in the audience? Looks like we're just about out of time. Yeah. Okay. Thank you all for being panelists and for your talks. I want to thank everybody who supported the thing. There's actually a lot of people behind the scenes that have been doing some great stuff and made this go off better than I expected, which is good. So thank you all for being here. I'm going to